So this is the 2000 higher paper question 21. It's a projectile style question again. Somebody's flipping a coin into a dish at a certain height, 7 meters per second at an angle of 60 degrees. So as with all these types of questions, you can resolve that into its horizontal and vertical components of motion. That's your first question there. Calculate the horizontal component of the initial velocity of coin. So if it's horizontal, we remember that by cos across. That works quite well for these types of problems. So that's v cos theta, which translates to 70. Is it 7? 7. 7 cos 60 gives 3.5 meters per second. So if you've already done cos, that leaves sine for the vertical component of velocity. V sine theta, 7 sine theta is 6.06 meters per second. So that's your answers to part 1 and part 2. Part B, show that the time taken for the coin to reach the dish is 0.8 seconds. Now you'll notice there that you're given the range or the horizontal distance. It's 2.8 meters. So the easiest way to figure time out is to do horizontal displacement divided by horizontal velocity, because horizontal velocity stays constant. So if it starts off at 3.5 meters per second in the horizontal direction, it's still going to be 3.5 up here, and it's going to be 3.5 all the way till it reaches the dish, because horizontal velocity remains constant in all projectiles. So that's 2.8 divided by 3.5 gives 0.8 seconds. Now those questions are good because you know when you get your answer that you've got the right answer and you've got the marks. C. What is the height h of the shelf above the point where the coin leaves the contestant's hand? So h might as well be s. It's an equation of motion, or it's a problem to do with motion, so we're going to use equations of motion. So we write down suvat, that's all your variables that you need. S is what we're trying to figure out. U in the vertical direction is 6.06 meters per second. We don't know what V is. V is an unknown here. Remember, it may well land in the dish and it may well end up with a velocity of 0, but it won't necessarily do that within this time interval here. Within the 0.8 seconds it might bounce, you know, it might do all sorts of weird and wonderful things. We can't assume that it ends up at 0. It's travelling in an upwards direction, so we give it negative 9.8 meters per second squared. The time horizontally was 0.8 seconds, so that's the one constant across horizontal and vertical motion is time. So we're looking for S, we've got U, A and T, so it's going to be S equals U, T plus a half AT squared. 6.06 multiplied by 0.8 plus a half times negative 9.8 multiplied by 0.8 squared gives 1.71 meters. So you get your full 2 marks for figuring out that 1.71 meters. Now part D I deliberately put in, it's a wee bit trickier. It asks you to kind of think about things a wee bit more. These are the types of questions, really, these 2 markers on the end that make a difference between B's and A's. So if you're looking for an A, you'll probably have to answer these. How does the value of the kinetic energy of the coin when it enters the disk compare with the kinetic energy of the coin just as it leaves the contestant's hand? And justify your answer. Well, you know that as this goes up, it's moving in a curved path because it's being pulled down by gravity. So whatever motion it has initially, whatever kinetic energy it has initially, is obviously being reduced as it goes up there. When it gets to this certain height, you know, anything at a height has an energy associated with it, a potential energy associated with it. So your answer to this is really that EK in the dish is less than EK when it starts off, because most of it is now potential energy. So most of the energy is now potential energy. So you're looking to write a sentence that's, you know, similar to that for the 2 marks. The kinetic energy in the dish is less because most of it is now being converted into potential energy.